Hi, in this video we're going to learn how to solve problems involving quadratic functions. It's important to pay attention to some of the terminology when you are working with quadratic word problems. For example, if you see the words max or min, or if you read maximize something, minimize something, this means that we're talking about the vertex. So you need to either convert the equation of the quadratic function into the vertex form or determine the vertex algebraically using other methods. When the problem is asking you to determine dimensions, this is when we're talking about the h value of the vertex, given the vertex is hk, and then h will be one of the dimensions. To find the other dimension, you'll have to use the relationship between the two dimensions. It's very important that you define your variables at the beginning of the problem. And if necessary, you need to rearrange and isolate for one of the variables, expressing one in terms of the other one. A rectangular field will be fenced on all four sides. There will also be a line of fence across the field, parallel to the shorter side. If 900 meters of fencing are available, what dimensions of the field will produce the maximum area? What is the maximum area? So first we're going to figure out what information here is important and what information is irrelevant. So it is important to note that this is a rectangular field. So the shape we're working with is a rectangle. It's fenced on all four sides, and there is another line of fence across the field parallel to the shorter side. It helps to create a diagram in this case just to see what it will look like. So we have a rectangle, and we have another line of fence that is parallel to the shorter side. We can label the shorter side the width and the longer sides the length. So we have 2 length and 3 widths. 900 meters of fencing are available. When you're given the amount of fencing, that is essentially the perimeter. It's in meters, and you have 900 meters of fencing to enclose all of the sides involved. Then the problem is asking us what dimensions of the field will produce maximum area. So basically, we're trying to find the expression that represents the maximum area, and from that expression, we also need to figure out what dimensions will be to produce that maximum area. So we have to deal with 2 formulas here. First one is the perimeter. The perimeter of any shape is the sum of all sides that are being enclosed. In this case, we have 2 length plus 3 widths. We also know the value for the perimeter, so we can write it out like this. However, we're not really solving for the perimeter. We're trying to find the area, right? The area of any rectangle is length times width. Now, in both of these equations, we have 2 variables that are given to us and that are unknown. And it's difficult to find to solve equations with 2 variables. So I'm going to try and express the one variable in terms of the other. from the perimeter equation. And then I'm going to substitute the expression for that variable into the other equation for the area. So from here, I'll get 900 subtract 2L equals 3W. And then we're going to divide by 3 on both sides. And then W will equal 900 minus 2L over 3. So you can see that W is this expression. This expression can replace W in the area equation. And that's what we're going to do. A equals L times 900 minus 2L over 3. All right, let's now distribute the L over the expression in brackets. So A equals 900L minus 2L squared over 3. And we can split it into two terms over the same common denominator. A equals 900L over 3 minus 2 over 3L squared. Let's reduce the first term and rearrange so that it goes from highest to lowest. Minus 2 over 3L squared and plus 300L. So this is now the equation for the maximum area. We need to determine the value for the area. In order for us to do that, we need to convert this equation, which is in the standard form, into the vertex form equation. So in order for us to convert this equation from the standard form into the vertex form, we can do completing the square process. So here, we're first going to common factor negative 2 over 3. And then inside the bracket, we'll get L squared. And let's do the division by negative 2 over 3 on the side. So 300 divided by negative 2 over 3, since we're common factoring negative 2 over 3 from both terms. So this will give us the same as 300 times negative 3 over 2. 300 times 3 is 900 over 2 with a negative, which is negative 450. So here we end up with negative 450L. Now let's continue with completing the square. L squared minus 450L. We need to split this term into 2 times something that is, when multiplied by 2, gives us negative 450. Negative 225 and times L. Then we take this number, negative 225, and we create a perfect square of it. Then we add the perfect square of this number, and we subtract the perfect square of this number, and close bracket. Okay, next, we keep the a value, negative 2 over 3, and we are converting. This will become a perfect square trinomial that can be factored into L minus the number that was squared at the end, to negative 225, and then squared. Then in order for us to get the k value of the vertex, we still need to multiply -2/3 by the square of -225, and that square will be negative since we have still a negative in front of it. So let's just do that. And so we'll get positive 33,750. So what is what here? All right, let's label it. 225 in the bracket will be our H, and 33,750 will be our K. H represents one of the dimensions, and K represents maximum area that we can get with that dimension and the other dimension that we can determine. Okay, so let's find the other dimension. The other dimension was based on the L, and it was when we rearranged for L and W, remember? 900 minus 2L over 3. So we're going to substitute the value of L to get our W. So then this will be 225. Make sure you're using only positive values for your dimensions. Length and width must be positive. They cannot be negative. 3, and therefore W equals 150. Let's finish off with the therefore statement. So the max area is 33,750 meters squared. Units are very important. The dimensions are 225 meters and 150 meters. Let's look at another problem. A grocer sells 50 loaves of bread a day. The cost is 65 cents a loaf. The grocer estimates that for each 5-cent price increase, 2 fewer loaves of bread will be sold. Determine what cost will maximize the revenue. So we have two quantities that we're talking about here, loaves of bread and cost. So when the grocer sells 50 loaves, the cost of each loaf is 65 cents per loaf. Now, then the grocer introduces some price increases. It can be multiple price increases. Start with 1 and then continue on. So let X be the number of price increases. Depending on how many increases happen, we will have 50 loaves sold minus 2 fewer loaves per each price increase. So minus 2x. And then the cost will start with 0.65, but depending on the number of increases, we have 5-cent increase each time, 0.05 times the number of increases. We want to find the best revenue. We want to find the maximum revenue, and we want to find the cost that maximizes the revenue. Revenue is items times cost. So then R in our case is items here are loaves, so 50 minus 2x, times the cost 0.65 plus 0.05x. In order for us to determine the maximum revenue that we could get and then determine the cost that will produce that maximum revenue, we need to convert this equation into the standard form first and then into the vertex form. And then from there, we'll be able to get the maximum revenue. We'll be able to see how many increases in price will result in the cost that will maximize the revenue. So let's expand this first. Revenue equals, we multiply all the terms by each other and we drop the brackets. So here's what we're going to get, and then we collect like terms and rearrange in a descending order. Negative 0.1x squared plus 1.2x plus 32.5. So this is what we are getting if we expand this equation. Now, if I were to find the maximum revenue and the cost that produces it, I would need to convert this now into the vertex form, and I can try doing that by completing the square. R equals common factor the negative 0.1 out of the first two terms, only the ones that contain the variables. The constant remains unchanged up until the end of the process. So x squared minus 12x, and then we split this into two, so 2 times negative 6 times x, right? Then plus the square of the number, negative 6, and then minus. Because we're bringing that number in from nowhere, we have to balance our expression. And then plus 32.5. So then our a value is negative 0.1. The perfect square trinomial, which is this one, will factor into x minus 6 squared, and we still need to multiply this value by that and then still add 32.5 at the end. So then we'll get plus 36.1. We multiplied negative 0.1 by negative 36 and added 32.5. So what do we have here? 36.1 is the max revenue that we can collect in dollars, $36.1. X minus 6 represents 6 increases in price. So remember that x equals x is not the price, it's the number of increases. Now we need to determine the cost that will produce the max revenue. The cost was given to us as 0.65 originally, and then 5-cent increase times the number of increases. So we had an expression for it, and it was 0.65 plus 0.05 times x. So now x is the number of increases, and we have found that in order for us to get the maximum revenue of $36.1, we need to have 6 price increases. So the cost will then be 0.65 plus 0.05 times 6. And that will result in 0.95. So this is the cost that will maximize the revenue.